Everyone, this is the first video for section 4.1, mental math and estimation. So first, we're going to go through this mental math section. So like always, make sure that you've already read the textbook at this point to see all the different strategies for doing mental math with our four operations. I'm not going to go through all of the strategies that the book covers, just a few examples of the main ones that we use. Okay, so the first example says to calculate each of these mentally. So we're going to have an example of each operation: addition, subtraction, multiplication, and division. And we want to write out all the steps we took and justify each step using a definition or a property. So if you want to think about this on your own, I would recommend thinking about it right before I work each question. Think about, well, how would you add these in your head? I know it may have been a while since you've done some mental math, but think about what process you would go through to do these operations in your head, and then see if it matches what I would do. Okay, so this first one is 48 plus 33. So the strategy we are going to use here is compensation. So it's essentially just using more compatible numbers. So instead of adding 48 and 33, we can see, so that 48 plus 33, we can see that 48 is really close to 50, and 50 is a lot easier to work with. So to get 50, we would need to add 48 and 2. But then in order to compensate for adding that 2, we would have to then subtract 2 from 33. So this is essentially just using the additive identity, right? In order to compensate for making 48 a more compatible number of 50, we have to then, we add 2, and then we also have to subtract 2. So remember, this is the additive identity. We're adding 0, doesn't change the value. And so adding plus 2 and minus 2 is the same as adding 0. So this goes to 50 plus 31. So for this step, we just added and subtracted. And now when we have 50 and 31, we can add them to just get 81. Okay, so that's the way we do it. We do find more compatible numbers by looking at our numbers, thinking what's easier to work with than the numbers I have, adjust them, and then compensate with the other number to make sure that we didn't change the value of anything. Okay, so we're going to do the same thing for this subtraction. So again, we're going to use compensation and compatible numbers. So 102 and 77. So again, 102 is really close to 100, which is a lot easier to work with. It's kind of what we do naturally, right? And a reason for this is thinking of money. So I know that thinking money is a strategy for multiplication, but it can also help you identify compatible numbers, right? 50 and 100 and things like that just make more sense to us because our money kind of works that way, right? We have a $50, which is 50 cents, and we have $1, which is 100 cents, and similarly, we have a $50 and $100 bill. So using these values makes more sense to us because we're so used to using money in those values. Okay, anyway, to do 102 minus 77. So we want to change this 102 to 100. So we subtract 2 there. And now we have to compensate by, it's going to look a little bit funny, by subtracting 2 over here at 77. And this is still actually a case of the additive identity, because you can see here, I'm going to write a little note in blue over here, that minus 2 is the same thing as positive 2. So whenever we subtract 2 from the 77, it's really the same thing as adding 2 in this equation. So we subtract 2 from the 102, and then we add 2 to the 77. So that's why we have compensated for the subtracting 2 and the 102 by adding 2 and the 77. It just looks a little bit different because of the subtraction sign, but it's really the same thing. So then we add and subtract these parentheses. So we get 100 minus 75, right? And this is even easier, right? This is 4 quarters minus 3 quarters gives us 25, 1 quarter. So again, we had the exact same operations here where we added and subtracted the parentheses, and then we did our operation of subtracting there. Okay, this next one is multiplication. So we've already talked about thinking money. So this one is going to be a rearrangement of the factors. So we can rearrange these factors. So we have a 2 times 13 times 50 times 3. So rearranging the factors is essentially just using the commutativity of multiplication that we talked about in chapter 3. So what we can do here is we can switch things around, right? It doesn't matter what order we multiply things in. So the way that we said this before is either x plus y, x times y equals y times x, or a times b equals b times a. I'm not quite sure which variables we used, but regardless, we can switch things around however we want. So first things first, I'm going to switch the 13 and the 2. So this is using the commutativity property, and that's commutativity of multiplication. And so after this step, I'm going to switch the 50 and the 3. Hold on, let me think about how I did this. Oh, my apologies. This first step, I'm going to switch the 2 and the 13, and I'm going to switch the 3 and the 50. And then next, I'm going to switch the 2 and the 3. And you can see that just by switching two numbers right next to each other, you can really just multiply these in any order that you want, and you have complete freedom in rearranging these factors any way that you want. But whenever I do this, again, this one is commutativity. So when I do this, now in part C, I can use the associativity property, where the associativity property says it doesn't matter in which order you multiply things. So when we do this first multiplication, we get 39. And when we do the second one, we get 100. You can see I rearranged these factors so that we would multiply by 100, right? It's a lot easier, just like it is with adding and subtracting. It's a lot easier to multiply by 100 when you can do that, because all you do is just add 2 zeros here. So what we did, we used the commutativity property a couple times to rearrange our factors. Then we used associativity to group which things will multiply first. And then we just performed the multiplication there. So this is using the rearranging of the factors strategy. I'll go ahead and write that down. Rearrangement of the factors. Okay, so D is our multiplication example. So in this case, our mental math strategy for division is using rewriting the dividend, again, to create more compatible numbers. So we are trying to divide 261 divided by 9. So we look at this and we say, I have no idea what that would be, but we can think of what's a number that's close to 261 that we know is divisible by 9. And we can see that, thinking about it, that if we instead think of 261 is 270 minus 9. And we think about it in this way because 270 is divisible by 9 and 9 is divisible by 9. So we want to try and rewrite our dividend, the number that we divide by, as a sum or difference of two things that are indeed divisible by 9. So in order to do this, we look at 261 divided by 9 is 270 minus 9 divided by 9. And this was just using substitution, where we substituted 261 for 270 minus 9. And then we can use our distribution property. So this is equal to 270 divided by 9 minus 9 divided by 9. And this is using the distributive property, right? So we can use distribution. The full name of this is distribution of division over subtraction, right? We distributed that division sign, right? We had 1, now we have 2 of them over this subtraction. So then we keep going. Now we actually do our division. So 270 divided by 9 is 30. 9 divided by 9 is 1. And then we do our subtraction. So here we did division, and then we did subtraction. Okay, so we did this one. So this rewriting the dividend comes down to, can we rewrite our dividend in the form of a sum or difference of two things that are divisible by the number we want to divide by? Okay, so this was really quick discussion about these mental math strategies, right? So make sure you read the book and that you understand all of the examples in the book. And next video, we'll start talking about estimation. But for now, that's all for this video.